All right. Here we go. So like I said, today we'll be working on quadratics and solving those. Interesting. All right. So we'll just review that a little bit here before jumping in. Normally when we have tests, by the way, normally I like to go over like the answers and stuff like that too, so you can see where you made your errors and things like that. Maybe I'll do that. I don't know. Maybe I'll do that next week or something like that. But again, I just want to move on to things because we have to cover some material here, and I don't want to get behind. Anyway, there we go. So quadratic equations, what we're talking about, something that you've seen in the past, right? These are equations that can be written in the form ax squared plus bx plus c equals 0, right? Where a, b, and c are what we say real numbers. Okay, it could be positive, could be negative. Oh, I'm off the screen. There we go. Of course, will every quadratic equation that we come across be in this format? No, but we can always like rewrite it, right? So that it's equal to 0, and then combine like terms and all that jazz too. Okay, you can just jump those there. Thank you. Okay. There's a couple strategies that we're going to use there's a couple strategies available to us, I should say. All right, so the first one, right, let me just start with an example here. All right, where we have like 3x squared plus 5x equals 0. Okay. In order to solve this quadratic equation, what might be a good first step? Yes, factor out an x. We have a GCF here, okay? And so we'll factor an x out like that, okay? And then from this point, what should we do? How can we now, again, because our goal right here is, to get x by itself. So now what should we do to this? What should we do here in our equation? Is it right?
Divide both sides by x.
Okay, so some might think, right, we can divide both sides by x here, and that would be something we could do. So if we divide both sides by x, we're going to end up with 3x plus 5 equals 0, and now we would just solve the equation, right? So we get x equals negative 5/3, right? We'll subtract 5, divide both sides by 3, we get x equals negative 5/3. Okay, and when we could check this, we could check this in our calculators here. Show you negative 5/3. Okay, whoops. Oh man, I'm in funky mode here. So we'll do 3 times negative 5/3 squared plus 5 times negative 5/3. And we get 0, so it works. Okay. What else is going to work here, though? What else makes the equation true? Julia? 0. How come we only had one solution here, though? Yeah, Megan?
Because you divided out the x.
Right, we divided out the x. Okay, so could we divide both sides by x here? Absolutely. All right, absolutely, you can do that here. All right, it's not a wrong thing to do, but well, I don't say it's not wrong. It's not incorrect. I don't know, whatever. I mean, you can do that, but it's not going to be helpful. I guess I'll say in this case, we lose a solution here. So backing up to what we originally had. X times 3x plus 5 equals 0. Since we have two things here that multiply, right? We're multiplying these two things to give us 0. That means each one of these two things could be 0. And so we break it up, okay, into two equations and say, aha, there's one solution, and then we get our x equals negative 5/3. Okay? We're taking advantage of a special property that is only true for 0, right? only 0 has the property that if two things multiply to give you 0, one of those two numbers has to be 0, or one of those two values has to be 0, right? Any other number you pick does not have that same guarantee, right? If this was equal to 4, and if I have two things that multiply to 4, that does not mean that one of those two things has to be 4, because we can multiply to get 4 by doing like 2 times 2, right? But if it's equal to 0, then that means one of these two things is equal to 0. You can't take two non-zero numbers, multiply them, and get 0. It's impossible, right? One of them has to be 0, and that's why we're taking advantage of that zero product property here. All right, so Riley, you see what we're supposed to do there now? All right, now, one other thing, but thank you for volunteering that, okay, because that's what I wanted to point out here, hopefully, so you helped me out, okay? One other thing I want to point out here is that some students are tempted in cases like this also to like subtract 5x from both sides. Okay, and I won't make you like raise your hands or anything like that. Not that I could ever make you raise your hand, but some of you might have been thinking this, right? Mr. Wade, what if we just subtracted 5x from both sides and then divided both sides by x? So we got 3x equals negative 5, and aha, x equals negative 5/3. Okay. But again, the problem is we lost that one solution, right? Just like what we did with Riley here, where we divided both sides by x, we lost that possible solution, so we only end up with a negative 5/3. We missed the 0. Okay, so we don't want to do that. This is the path we want to take right here. Okay, factor, set each factor equal to 0. All right. Shoot, I had something else I wanted to say here, but I can't remember now. Oh, here's what it is. You want to be very careful whenever you, in an equation, divide both sides by x. Okay? Because do we know what the value for x is? Right? We're trying to solve for x. So we could potentially, whenever we divide both sides by x, we could be dividing both sides by 0. Are we allowed to like divide by 0? No. Okay? And so that's why you want to be very, very careful about ever dividing in an equation, if you want dividing both sides by x or x squared or something like that, because those could be 0, right? And then you could be potentially doing some like funny math and stuff like that. This is like, it's so funny that if you have ever seen proofs, and I'll put those in quotes, proofs on the internet or something like that, typically that's where you see it, of like proofs that like 1 equals 2, or like 0 equals 1 or something like that, those proofs oftentimes have an error in them, and the error is that when you divide both sides, at some point you divide both sides in the proof by something, and that something could be 0, and so that makes it result in kind of like that weird conclusion that 1 equals 2. And if you're curious, I could show it to you another time kind of thing. But that's why we want to be very careful here. You don't want to divide by 0 because you can result in some mathematics that just aren't true. So enough on that, okay? So if we see a problem then like this, 2x squared equals 8x, it's quadratic, right? It's got x squared in it, so it's a quadratic equation. It's got an equal sign in it. Okay. Should our first step here be to divide both sides by x? No, okay, right? We don't want to do that. We don't divide by x. So then what should our first step be here? Right, we want to subtract 8x, make it equal to 0, right? That's our goal here for these quadratic equations. Make it equal 0. Bless you. Okay. And now at this point, how should we proceed? Factor out a GCF, okay? I'm going to do both, and we can do an x. Also, in addition to that, we can factor out a what? A 2, okay? So does it matter whether you just factor out the 2 or just factor the x? I mean, at least the x, but I like to factor out the GCF just to make my numbers a little bit smaller here. Okay? And so then we get 2x equals 0 or x minus 4 equals 0. Again, two things multiplying here. The 2x is one of the things. The x minus 4 is the other thing. Both of them multiply to give us 0. One of those two things has to be 0. And so we'll set them both equal to 0 and say either x equals 0 or x equals 4 will result in a true statement there, in a true equation. Okay. So again, set equal to 0. You can just put them like right there. That's fine. Okay. So, set equal to 0 factor. Okay, in this case, use GCF if possible. Okay, of course, there are other things that we do that are also considered factoring, right? A greatest common factor, that is the first one you kind of learn, but we're going to see some other ones here too. Okay, so questions on any of that? GCF, right? I was just using GCF. All right. So I want to talk about a special scenario that we run across too, which is difference of squares. Okay, quadratic equations that are in a particular format. And this is a difference of squares. So difference of squares, again, we're not very creative when we name things in mathematics, right? Difference, subtract, squares. So we're going to be subtracting two perfect squares. Okay, I'm going to represent these very generically, okay, very generally, which is a squared minus b squared. Okay, you can replace the a and the b with whatever variable or number that you want there, or quantity really, and it still factor to this, right? A minus b, a plus b. It's not really necessary to remember this formula because I can show you how we can use our later stuff where it's like the product sum method and all that. I'll show you that later about how you can use that to then factor just like we do the difference of squares here. But you can also remember this formula too. It's helpful, right? And again, just to check to make sure it works out, right? Let's FOIL this. A times a squared, minus b times a, that'll be a negative ab, right? Positive b times a, positive ab, so they're going to cancel because one's negative, one's positive, so they're going to be exact opposites, they'll cancel. And then negative b times positive b, negative b squared, right? Because it's multiplying, negative times positive. All right, so let's just quick example here. X squared minus 36. Okay. How might we go about solving this equation? Okay, right. This is a difference of squares, right? In this case, x squared is a perfect square of x, and 36 is a perfect square of 6, right? So it's going to be x minus 6, x plus 6 equals 0, right? That is, if you need to see it in a easier format. So there's your a, x, there's your b, 6. So a minus b, a plus b. Okay, and now we have a product of two things, right? Before this is not a product, it was a difference, right? X squared minus 36, but now we have a product of two things equal to 0, so that means each one of these two things equals 0, so x equals 6 and x equals negative 6. Our solution's there. Did anyone see a different way to solve this? So yeah, Hayden? Add 36 to both sides. Yeah, alternatively here, right? We can just add 36 to both sides. But Mr. Witt, you said we should always make our quadratic equations equal to 0. And in general, it is a good strategy. But in this case, we can continue to solve here because now what should we do to both sides to solve for x? Square root. X equals 6. Plus or minus 6, right? When we're in an equation setting, right, we want to list all the possible numbers that make this equation true, right? Back to our previous step. What numbers, right, what x values, when you square them, give you a positive 36? Both a positive 6 when you square it gives you 36, but also a negative 6 when you square it gives you 36. So that's why you have to have a plus or minus 6 there. Okay, it's to, again, which is really just x equals 6, x equals negative 6. Which only happens with even roots, right? If it was a cube root, you don't need to worry about the plus or minus there. But if it was a fourth root, you would worry about the plus or minus and stuff like that. Okay? So, questions on any of that? All right. Moving on. So, let's get to the thing that most of us probably think about when it comes to solving quadratic equations. And that is product and sum. All right, product sum stuff. So, we'll start with the easy ones, right, when it's a equal to 1. And we'll talk about the more challenging ones. Okay, so that's like, that. When I say a equals 1, that's right, the lead coefficient here. When the lead coefficient is just 1 x squared and then plus bx plus c. All right, so we'll start just with an example to kind of see how this works. Okay. So typically when you first learn this stuff, right, you don't jump right in. Your teacher just doesn't show you, hey, here's a quadratic and here's how we're going to factor it. Typically, you come to this point after you've already had experience with taking two binomials and multiplying together using FOIL, right? Typically, you learn that first, and then you see, oh, wow, when I multiply two binomials together, I tend to end up with these kind of trinomials or quadratic, kind of expressions here. So it's like, maybe then, every time I see a quadratic, it could factor to two binomials, right? And that's right. Right? So we're going to go backwards from FOIL, right? We know we're going to need two things in front here. These first things are going to have to multiply together, and let's just say we're going to multiply to make that x there. So the only way to multiply to get x squared, or the easiest way to multiply to get x squared, is going to be x and x, right? Ooh, hang on a second. I think I made this more hard than I need to. Let me make this 36. My apologies there. Okay, 36. Sorry about that. That would have made it much more challenging if we did that. 33. Okay. Sorry, actually 36. All right, so anyway, we know the two x's need to multiply to give us x squared. All right. And then here, right, we're going to need two numbers that multiply the L, right, last and last. Last times last is going to give us that negative 36. But then simultaneously, this will multiply with the x and this will multiply with the x. They have to add to make negative 5. So we're going to need two numbers that multiply to make negative 36, but add to make negative 5. And what are those going to be? Yeah, okay. So negative 9, positive 4. Okay. And that's where it gets tricky, right? Because you have like lots of combinations here to multiply to make negative 36. You could say negative 3 and positive 12. You could say positive 3 and negative 12, right? Or you could do the 6 and negative 6. So we have lots of options there, okay? Or of course what we did, the negative 9 and the 4, but of course you also could have thought negative or positive 9 and negative 4, right? There's lots of options we could potentially run through there. Okay. But we always try to determine what numbers multiply to this first, right? Why is that, by the way? Why do we always try and figure out the numbers that multiply to this number and then add to the negative 5? Why don't we try and think about just all the numbers that add to negative 5 and then check to see that they multiply to negative 36? Why do we do it that way? Why do we always check to see first what numbers multiply to make negative 36 and add to then make negative 5? So yeah.
There's a lot more numbers you can add, subtract, to get negative 5 than they can multiply together to get negative 36.
Exactly right. Right? It's just for efficiency's sake, right? We want to figure out what numbers, there's fewer combinations that multiply to make negative 36 than that add to make negative 5, right? So, exactly right. All right, so now we factored here, x minus 9 equals 0, x plus 4 equals 0, and so x is 9, x equals negative 4. Those are our two solutions there. Okay. Again, you've been doing this since Algebra 1, so I don't want to say too long on this, but, or at least since Algebra 1, maybe even before that, but I'm guessing at least since Algebra 1. Okay. Those are the easy ones. Let's jump to a harder one now, right? When a is not equal to 1. Okay, and so let's say we've got here for our example, let's say we've got 2x squared minus x minus 4 equals 2. Okay. So what should be our very first step here? Subtract 2. Good. Okay, good. Your alarms are well tuned. All right, right. It's not equal to 0. All right, so before we even start to think about factoring this, we need to make sure it's equal to 0. So we'll subtract 2 over. We'll get 2x squared minus x minus 6 now. Equals 0. Okay? So, here is where we really have a couple strategies, right? We can still use that old strategy that we had up here, where we just kind of like almost guessed and checked a little bit, right? So, again, we know ahead of time, if this is going to factor, it's going to factor to two binomials. All right? So, we got to multiply to make 2x, so that's the only way we can do that is by 2x and an x here. Right? Got to have 2x, got to have an x. Or you can put the x here and the 2x here, but that doesn't matter. Okay. And so now we need to think of two numbers that multiply to make negative 6, right? But then add after multiplying with the 2 and the 1 here to then make a negative 1. So what are two numbers that multiply to make negative 6? 3 and negative 2. Okay? So I'm just going to randomly guess here. I'll put the plus 3 here and the negative 2 there. Okay? 2x times x gives me 2x squared. Negative 2 times 3 gives me negative 6. But we got to check to make sure we get a negative 1x here. So let's check. Negative 2x plus a 6x. That gives me 4x. Okay? Maybe I should do 2x plus 3 and x minus 2, like that. So I'll flip their positions. Let's check here now. 2x times x, 2x squared. Negative 2 times 3, negative 6. 3x minus 4x. Aha, negative 1x. We got it. So this was a bad guess. We're going to use this one. Okay, because that gives us everything we need there. So you get 2x plus 3 equals 0, x minus 2 equals 0. And so you get x equals negative 3 halves, and x equals 2. Questions on any of that? So that's guessing and checking. This is how I learned how to do it. All right, and so for some more of the complicated quadratic equations, I would have many eraser marks on my paper because I was a bad guesser. But of course, the more you do it, the better you get at it, and the mental math of it and stuff like that too. All right, so that's one option you have there for factoring like that. Let me give you another option to consider here. Be nice and already make it go to 0 there. Okay. Okay. So, when I was doing these problems, I would always hate getting these. The issue here, if we try and use that old tried and true guess and check method, we could use 6x and x as our starting point. Or we could use what? 2x and 3x or 3x and 2x, yeah. So, oh man, you could pick 6x and x here, and you could guess every single possible combination that multiply to make 6, and none of them would work because you may need to have started with the 2x and the 3x first. Right? And this is where guess and check gets really frustrating. All right? So let me show you another method that can maybe help alleviate, some of these more difficult quadratics that we'll have to factor sometimes. All right, so I'll kind of run through these steps. And again, there are different teachers use different methods. Some people use something called the magic X or whatever. All right, so this is just an alternate way of doing it. Whatever. They're all kind of similar. These strategies that are used here. So I'm not going to go through all the little details of it. Okay, I'll show you this one, and maybe I'll show you another one too, called slide and divide. But this one we're going to start here with just this way. So one way to kind of make this easier for ourselves is if you multiply A and C. Okay. So, and that means, what do I mean by A and C? A is the lead coefficient, right? It's A x squared plus bx plus c. So the A and the C are 6 and 6. So we get 36. Okay. So in this case, that's 36. Okay, 6 times 6, 36. 2, you want to find factors of A and C. Or sorry, find factors of AC, I should say. Find factors of that product, AC. Okay, that add to make B. Okay. So we need two numbers that multiply to 36, but add to make negative 13. So what would those be? Multiply to 36, add to negative 13. Parker? Negative 9, negative 4. Okay, in this case. And we're going to call these kind of like M and N if you like to, okay, for our general purposes here. And so then what we'll do is we will rewrite ax squared plus bx plus c equals 0 into, let's see if we can see more here since we're not really working elsewhere. Okay, ax squared plus mx plus nx. So essentially we're going to break up that middle term using those two numbers there, -9, -4. Okay. And then we'll factor by grouping. The first two and last two terms. Okay, so I'll show you what I mean by that here in just a second. Again, this is one method. The steps I think are harder to understand than actually just seeing it be done, but there it is written out at least. Okay, and again, this is one method. This is one method. You might have a different method that you prefer. If you do like the magic X, it's like it's essentially like that, but it does help organize it a little bit more. I don't know. So anyway, and I'll show you slide and divide maybe after this one. Okay. And slide and divide is real slick because it has a rhyming name and it helps you solve things like this too. Ready to actually see it in practice now? Anyone still writing? All right, let me zoom out and show you what I mean then. So we started with this problem, right? We did 6 times 6, 36. And we used that as our goal for the product, right? So we did 6 times 6, 36. We needed two numbers that multiply to make 36, but add to make this middle term. And Parker told us -9, -4. So then we're going to take 6x squared, rewrite it, and then -13 will break it up as -9x minus 4x plus 6 equals 0. Okay. Mr. Wade, what if I wrote -4x and then -9x? If I reverse the order here, that's okay. You'll still have the same answer at the end. It'll be slightly different in the middle, but at the end it'll be the same. All right. Now, by breaking up that middle term, right, -13 is -9 and a -4, right, together. By breaking that up, we now have 4 terms, and we're going to factor by grouping. So we're going to group the first two, group the last two. Okay. Now, before, we didn't have a GCF. But now that I've grouped these two together, I do have a GCF in this first group, right? What's the GCF we can factor out there? 3x, right? And what's the GCF we can factor out here? 2, okay? Or else, actually, I'm going to factor out a -2. So if I factor a -2 out, then I'm left with a positive 2x, and then that'll be a -3. Okay? And now we see both of these terms have a 2x minus 3 in common, right? And that should happen, right? That's the point of this. We should have both terms with a common factor of 2x minus 3. So we're going to factor out a 2x minus 3. Okay? If I take 2x minus 3 out of this, what's going to be left over? 3x. And then I'll take the 2x minus 3 out of that, and it's -2. And there it is, nice and neatly factored for us. And so we can then solve 2x minus 3 equals 0, 3x minus 2 equals 0, so x equals 3/2 and x equals 2/3. Okay. Maybe you want to just guess and check these, right? Maybe you don't have to learn this new method or whatever if it's uncomfortable for you or it's like, I don't get that. I get it. That's fine. You don't have to. Okay. Again, I'll show you slide and divide here. So I'll do this method one more time with another problem, all right, without all this extra explanation here. I'll kind of just run through these steps again, and then I'll show you slide and divide too. Okay, so I'm going to just try and squeeze it in right here. So I've got 3x squared for my next one here. Actually, any questions before I move on? Sorry. Questions? We're just hating life right now. It's a Friday, and Mr. Wade's throwing this crazy stuff at us. Okay. So let's say we've got 3x squared minus 14x plus 15 equals 0. So it's equal to 0. We're good to go there. Right. Again, we're going to use this previous method I just talked about. So we're going to take the 3 and the 15, multiply them together, and we get 45. And now we're looking for two numbers that multiply to 45, but add to negative 14. So, numbers that multiply to 45, but add to negative 14. All right, let's go Cooper, yeah. 5 and 9? Yeah, in this case, we'll need it to be, though, negative 5 and negative 9. Okay, so I'll go ahead and say, all right, 3x squared minus 5x minus 9x plus 15 equals 0, like that. Okay, again, so we break up that middle term. We break up that middle term that to the negative 5 and the negative 9x that we, chose there. That Cooper, chose for us there. All right, and then we'll, again, factor by grouping. Out of that first group, what can we take out? X. Out of the second group, what can we take out? Negative, not a 5, 3, right? Because 9 can't be divided by 5, but it can be divided by 3. So we'll take out a negative 3. That leaves then a positive 3x behind and a negative 5 here. And look at that, 3x minus 5, 3x minus 5. So we can take that out. And if we take a 3x minus 5 out of this product here, we're left with an x, and then this will be a minus 3 left over there, and that's equal to 0. And so, dot, 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 we get x equals 5/3, x equals 3, right? So again, just an option there. If you prefer guess and check, do it. If you got another option that works for you, like the magic X or whatever you want to use, do that. Okay. Let me show you slide and divide with the same problem. Okay. Let me show you slide and divide with the same problem. Squeeze it over here. Okay. Slide and divide. Here we go. Okay. Slide and divide. You ready? You slide the 3 back to the 15. And we create this problem right here. Now this problem is not equivalent to this problem, but we're going to use this one. We're going to use this one to help us solve this one. All right, so again, slide back the 3, multiply with the 15. And then we'll factor this. Okay, and now we can factor this thing. So now we're going to factor this. We need two numbers that multiply to 45 and add to make negative 14. We know the answer already because it's x minus 5 and x minus 9. Okay. Now, our answers are not 5 and 9, right? They're 5/3 and 3. Well, we're not quite done with the process here yet, right? We slide, and then we divide. And here's where we do the division. What do we divide by? We divide by 3. We're going to divide each of our numbers here by 3. Which is a little weird. All right. So again, slide back the 3 to the 15 to multiply them. You get this. Factor this using the normal kind of methods. Then we divide by that 3 that we slid by. Okay, you ready for this? Here we go. 9 divided by 3, that simplifies to 3. X minus 3. 5 divided by 3, does that simplify at all? Nope. So the 3 will slide back in front here of the x. 3, x minus 5, and x minus 3. Okay. And then you can solve and get your same answers here. Magic. So that's slide and divide. I don't know if that helps you or not, but that's another option there too. Okay, that's another option there too. Again, it takes something that has an a that's not 1. It gives you a problem that has an a of 1, makes it easy to factor. You then factor that and then divide by your old a, simplifying those fractions. If they simplify completely, you just leave it the way it is. If they don't simplify completely, then whatever the denominator is slides back in front of the x there, becomes the coefficient, and there are your answers. So it works. Okay? It works. The only catch you got to watch out for here is make sure you factor out any GCFs first, right? If you have a GCF, factor that out first before you do that method. Okay? Whew, that was fun. All right, so let me see. Do I have some for you to try? Let me see. I want to give you guys one to try here. 3x squared, 2x squared minus 6. Okay, yes, I think I do have some that I would like you to try then. All right. How about... Oh, there it is. Okay. So let me give you guys two to try here. We got time, right? Oh, yeah, we got plenty of time. So good. All right, so you guys try here. Using whatever method you prefer. Okay. Gosh, I'll be careful. I don't give you one I already gave you. Minus 5x minus 26. Okay, let's try. I'll give you 3. So again, my direction will be solve for x. Oh yeah, I don't have this thing. And then okay. There you go. Okay, so give those a try. Give those a try. 1, 2, 3. See what you can come up with. 30 more seconds here. 30 more seconds. All right. Cammy, how about the first one there? Do you have were you able to get to factor?
Yeah.
All right, what'd you factor it to be?
X plus 8 and x plus 3
X
equals
plus
0.
8, x plus 3 equals 0, and so then we get x plus 8 is 0, x plus 3 is 0, and so x equals negative 8, and x equals negative 3. Okay, we're all good with that? Okay. How about Kyle, were you able to factor number 2?
Yeah.
All right, what'd you get it to factor to be?
8x minus 6 and 8x plus 1.
So say again one more time. X.
What do you want me to give it to you? Like,
You can just give me the factored version. That's fine. Just like what did you get it to factor?
4x minus 3 minus 2x plus 1.
Okay, 4x minus 3, 2x plus 1 is what it ultimately factors to be, whatever method you choose to use there, okay, whatever that might be. Very good. And so then we get 4x minus 3 equals 0, 2x plus 1 equals 0, so x equals 3/4, x equals negative 1/2. Let's just check, Kyle, to make sure you got it right here, right? 4x times 2x, that gives us 8x squared. Negative 6x plus 4x will be a negative 2x, and then negative 3 times 1, negative 3. Looks good to me, okay? Does anyone want to see it done in a particular fashion? Anyone want to see number 2 done, like use a slide and divide, Mr. Witt, or slide and divide? Yeah, sure, real quick. 8 slides back to the negative 3, so it becomes x squared minus 2x minus 24, right? So far, so good. You need 2 numbers that multiply to make negative 24, but add to make negative 12, so that's going to be negative 6, positive 4. So far, so good. Like that. Okay, equals 0. Then we're going to divide those numbers by the number we slid by. So we slid the 8 back, so divide each of these by 8. Simplify the fraction. So 6/8 simplifies to 3/4. The 4 will slide back in front, so 4x minus 3. 4/8 simplifies to 1/2. The 2 slides back in front, 2x plus 1. And then there's your factors from there.
Alrighty.
Okie dokie. Other questions? Yeah.
For like that, when you simplify to like the x, I don't know, 3/4, like could you just leave it as x minus 3/4? So just like 4 have to like slide back.
So I see what you're saying, right? At this point, you can see the root, right? There, or the answer, right? It's 3/4, and there's like the 1/2, right? Like, is that what you're kind of saying? Like, there are the
Yeah.
answers. Do we need to continue?
Yeah.
I would like you to, yes. And the reason why is because this quadratic is not the same as this quadratic. So I want you to be okay with like rewriting it back to like what the equivalent quadratic would be, and then solving.
Okay.
I would like you to do that, just because this does not equal this. If you take x minus 3/4 and multiply that with x plus 1/2, that does not give you this, right? It gives you the same answers, but not the same quadratic.
Okay.
And so I want to make sure we're kind of like doing good math here. Even though we're kind of using a shortcut, that doesn't really, it's kind of like magic really is what it is, all right? But it's a trick. But I would like you to go back to like the good math and stuff like that, okay? But of course, there's like multiple choice or something like that. You do whatever you want, get your answers, and then go from there. All right, last one, number 3. Let's go to Madison. Madison, did you get this one to factor?
Yeah, I got x equals 2 and x equals 3/2.
X equals 2 and x equals 3/2. So what method did you choose to use here? How did you factor it, I
I
guess?
did the first method we did. It was like multiply by a plus c, and then try and like it's like the ax squared plus bx plus.
Okay, so you did the, okay, so what were your factors then? How about you just give me that? So it's going to be 2x,
2x, and then
2x what?
I had it different than that. It was just like 2x and then the parenthesis x minus 2
minus 3x minus 2. Let me come take a look at what you're saying. No, I'm trouble visualizing it, but I think you have great answers there. So. Okay, the background group. Gotcha. You broke up the middle term.
Yeah.
That's okay. Okay, just checking here. Okay, very good. So, well, then let me. No, it was fine, but I just want to make sure. 2x minus 3x plus 2. There you go. So I think it should be, let's see here. Let me go through that here real quick. So if we multiply the 2 and the 6, we get negative 12. And then the two numbers that add to make negative 1 and multiply to make negative 12, you got that to be negative 3. No, negative 4 and positive 3 is what it should be there. So we get then 2x squared minus 4x plus 3x minus 6 equals 0, right? That would add together to give us what we need there. Oops, I'm off the screen. Let me go over here and just do this way. Okay. And so did you put the minus 4x and then 3x, or did you put...
Yeah, minus 4, yeah.
Okay. So then we'll factor by grouping there, right? So the grouping here is going to be 2x we can take out with an x minus 2 left over. Here a 3 with an x minus 2 left over. And so then x minus 2 and then 2x plus 3. And so we get then x equals 2 and x equals negative 3 over 2. There we go. Okay. Okay, there we go. Very good. Mm-hmm. All right. Cool. Good. All right. Let's do one more here. We'll do this one together. Factor and solve for x. Okay, again, I already nicely have it equal to 0 for you there. I was very nice too. I gave you a equals 1. Okay, so in this case, we're looking for two numbers that multiply to 10 and add to make negative 6. Okay, so what two numbers multiply to 10 but add to make negative 6? Multiply to 10 and add to make negative 6. Julia? Negative 5, negative 1. Negative 5 and negative 1 add to make negative 6, but they would multiply to make a positive 5, not a positive 10. Right? Negative 5 times negative 1 is positive 5. Not 10. Ramike? Yeah, right. The answer is there is no answer, or at least we can't factor it. So what do we do then? Yes, everybody's favorite. We're not going to be able to factor here, so we get to use quadratic formula. Mr. Witt, are we going to have the quadratic formula on like quizzes and tests, right? Like a formula sheet? Nope. You need to know it. Okay? So, quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. There are many songs. There are raps, and you can, try and spend all day on YouTube just watching all the different people trying to be famous on YouTube with their raps and songs and things like that. All right. This actually goes along nicely to like Frere Jacques. No, Pop Goes the Weasel. Wait, are those the same song? I feel like they are. No, they're not. They're not. But Pop Goes the Weasel is another song. Anyway, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? So there you go. Okay, there's one of the many songs you can find. But anyway, so you'll need to remember that. All right. Don't forget this x equals part in front. I feel like we can kind of like lose the meaning sometimes if we only use negative b plus or minus the square root of b squared minus 4ac all over 2a. Right? We lose some meaning here if you don't put that x equals there. Okay. So this is helpful. The quadratic formula is helpful for finding solutions to our quadratic. Right? It's helpful for finding solutions. But it's not always helpful for factoring, right? Because you can use the quadratic formula on any quadratic. So if you like don't want to have to learn more than one method, you could just use a quadratic formula. Of course, it's going to be important that we are able to factor too, so you want to be able to do the factoring. But I mean, if you're solving a quadratic equation, you can always use the formula, right? You can apply the formula to this problem up here, right there. Okay. The problem is, though, the formula is only going to give you the answers. It doesn't tell you how to factor it, right? So although x is 2 and x equals -3/2 solve the equation, that doesn't necessarily help you factor it, right? Sometimes you can work backwards. X equals 2. X minus 2 must be the factor. But this one's a little bit trickier to work backwards from, right? I mean, again, you can still do it. It's just harder. But here, the thing that doesn't factor, we can at least try and see if the quadratic formula works here. So x equals -6 plus or minus the square root of -6 squared minus 4 times 1 times 10. All over 2 times 1. Okay? Now, bless you. The quadratic formula not only is complex just because of all the stuff going on with it, but also in the simplification process, right? Students oftentimes make errors here in the simplification. So I'm going to try and like run through this here and make sure I speak to those when I can. All right, so we'll simplify here what's underneath the square root. -6 squared is 36. Minus 4 times 1 times 10 minus 40. Oh, Mr. Wid. It's going to be imaginary. So anyway, 36 minus 40, -4 over 2. Okay. And I'm just going to simplify this as if, you know, we were still going to simplify it. It's imaginary, obviously, right? And so, I mean, right now we're not working with imaginary numbers, so you can kind of like say no real solutions. But let's just say that we were considering imaginary solutions here, okay? Then the simplification for this, I want to speak to that here real quick. When students get to like this point, the most common mistake that I see is that students want to do this. I'll just write it over here on the side. They want to go, 3 plus or minus the square root of square root of -4. Okay? Right? Just like that. What's the problem with this? So let's go to Megan. Megan, you have this spoken yet?
The terms are added or like subtracted, so you can't just simplify it and divide it out.
Yeah. What is being divided by 2 here? Both terms. The 6 and the root -4. So when you simplify the 2 here with the 6, that's true. These things do simplify, but not in this way, because then the root -4 no longer is being divided by 2, but it also still needs to be divided by 2. So how can we really think about how we're supposed to simplify this? Well, I'm going to do it up here. This is going all sorts of crazy, but, you know, here we go. Break up the numerator over your plus minus. Make it 6 over 2 plus minus root -4 over 2. And then proceed with your simplification. Right? It would be 3 plus or minus, and then a 2i over 2. So 3 plus or minus I there. Okay? Break up the numerator over that denominator. Okay, before you simplify it there. All right, yes, from here. Good question. It depends on what the directions specify. Since they didn't specify here, you know, you can say 3 plus or minus I if you want. But I think, I mean, for our purposes right now, we're going to be focused on real solutions. So I think that should be your default. When we get into like, I think we're going to, I mean, later when we get into complex numbers, I'm pretty sure we do complex numbers. I have to check and see that. But anyway, right now we're going to keep it just real solutions. Okay. And I'll let you know when we have to worry about the imaginary stuff. Alrighty. Well, that was fun. Okay. So we have about 5 more minutes left. So I will stop there. All right. And I'll post your homework to Google Classroom. But of course, it's, you know, 5 minutes left. I don't know what you want to do there. Remember, I will be collecting the homework on Tuesday. Ugh. Yeah, no school Monday. Woo! Question.
In half